Hello guys, welcome back to our channel Chandra Awesome. Okay, let's continue with the previous video. As in the previous video, we have completed the design, how to design the each part of this radial engine. Okay, so now let's assemble it. So every part is ready. Okay, we just need to create an assembly. Create an assembly tab, but you can go on the plus icon. Once you create it, you will be directed to the assembly tab. Select Click on insert button and choose part studio 2, so the all parts will be imported into the assembly tab. Okay, once imported, click on save. So let's go these parts. Actually, okay, we need to fix one of the parts here. Let's fix this body, and now we need to assemble each parts one by one. Okay, so it's simple, no worries. Okay, let's start with these plate fixing. We need the push or pin to connect these both. I'm going to use first mate, select these outer circular edge and select the face of this. Okay, now save it. Let's move it forward. Use the same feature pattern and select the other edge of the second plate. And now save it. Sorry. Okay, with the plate, now what I'm going to do, I'm going to select the replicate tool and choose the pin, and we need to select the face. Select any face, the pin will automatically apply the parts within the required regions. Okay, like this. Now the plate is got fixed. I forgot one thing, we need to add the hole here. That's fine. We can add the hole later. Okay, the spin part is fixed. Now, uh, we need to link the crankshaft to this body, and it should be linked exactly like this. Okay, this crankshaft pin should be linked to these plates, which means this one. I'm going to choose the revolute mate option, select this edge and select this one. And click on solve to move the whole assembly to like this. So let's offset it. Choose the direction is already direction well. Let's offset to inside and click on solve to view the actual resulted one. Okay, now save it. Now let's assemble the piston, and with the piston pin everything. It is a tricky part to fit the pin here because you don't get the exact point to link it here. Okay, let me show you. Select the fastening mate. As you can see, you can only see the, here we cannot able to see the center point. Okay, just select the edge here and select the edge here, and there you go. If you see, it is not aligned with the pattern, but if you rotate it, oh, and you see if it's still not able to do that. So instead, we need to do one thing of assembly section here. Only select the first mate and select the inside edge. So there you can find the mate connector. And do the same thing here. Select the cylinder and choose this one. But if you observe still, the point is getting missed. I mean, the alignment is getting missed. You need to move a bit in, out, or in. Just edit the function mate, click select offset and give the value to 0.05. Or else you can find by selecting these both edges. So the minimum distance it is showing the y value is 0.07. 0.007. So let's do that. With the function mate, select offset and give the value 0.007, and it should be the negative value. And there you go. Now it fit perfectly. Okay. Now select the revolute mate, select the inside edge, and make sure you select the center midpoint, and for the cylinder as well, and save it. Now it's time to assemble. Instead of I'm choosing cylindrical made here. Why so? Because I will explain you. If I choose the revolute made here, the it may not be considered because we don't know the exact value from its center, right? Even despite we draw. Okay. Or else you can do one thing. Just switch back to partial 2. So if you see the actual diagram, let's do one thing. Select boolean, select this space, select subtract, target tool is this, and target one is this one. Okay. You need to remove this one, which means this is the tool from this one. Make sure keep the tools. Select. Now the hole is created. Now let's select the edge. So the value is zero point 0.2 from the center distance 0.2. So we should be using the revolute made here, selecting the edge and selecting this edge and give the off. You should be offset to 0.2 and set. Am I right or are you confused? It's 0.12, not 0.2. It's 0.12. Let's switch it to cylindrical mate, not a revolute, because the assembly is different and the design is got different. Okay, I will show you how to change it. Let's link the piston for now and make sure uh, copy this complete piston by dragging to the left side, right click and copy the 3 items and paste it. You may think that we can pattern it, but it works different. I will show you how. So I'm going to, we need, the piston should be sliding, right? So choose slider mate, select the top face and select any of the mate connector and solve it. Now choose revolute mate, send inside center mate connector and the center mate connector like this. Now we will get the actual point of here. Now let's see the value. It is 1.420. Let's keep it like this. Okay, so if it rotates, it should move like this. Okay, let's see the what is the top most value it is taking. Okay, it is going more than actual one. It is 8.0. Let's increase the value, head value to 1 inch. It's 0.8 and string 1 inch. Okay, we just need to edit the sketch 4 and give the value to 3.8. That's it. Save it. Come to the assembly, and there you go. The change is called apply. Wo- Okay. So you can think that we can simply select the instance and choose circle pattern, give the value to 5. But if there is a problem here, if you see how they are moving, it when you pattern or mirror it, it follows the motion of the actual one. Okay, so that's the issue here. Well, let's try with broken outline. I want to show you. Select the bevel made here, select the center made, and select here as well, and save it. And there you go. You see, they all got constrained because of this circular made pattern. So that's why we should avoid circular pattern, and we need to have the 5 pistons separately. Okay, we got 5. Now let's assemble them together. Set review made, select center one, do the same thing, and so got it. Do the same thing. You just need to repeat. Okay, just undo the changes. Once you align the all pistons, the pistons alignment should be get corrected. Select solve and should be aligned to the opposite direction. Okay, now select review made again. I'm just going to skip this part, okay? Because we are following the same procedure. Okay, just undo. But make sure you are selecting the center one. Okay, we got a change. You might face an errors here while doing the same assembly because of these parts. Make sure you manually move them because sometimes Onshape is unable to calculate the animations correctly. And you see, okay, everything got okay, but wait, let's delete this. Let me add the simulation once again for the slider mic. Think we are doing something wrong. Okay, let's correct it. No worries. I'm just going to edit this one and make sure it should be cylinder. Okay, there is something cell element here. That's it. Let me rotate it a bit to get the correct position. Okay, 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 that's fine. Let me do the same thing here once again. Select the face, piston head, select solve, change the orientation direction, save it, and do the same thing here itself for the other piston. Yeah, Now let's switch to front plane. Move it manually to rotate it manually. Do the same thing here. Okay, cut and collide. Select review made again. Select middle one. We need to select this as well. Cancel the outside wheel as well. Okay, let me send some remade. Okay, select triple huge. Select this center one and this center one and 7. So here we have to do one thing, that is now everything should be rotating, one should be the fixed one. So I'm going to change this first pinpoint should be the fixed one. Instead of rotate, I'm going to make it fast in it. Why so? Because in order to keep the animation correctly. Okay, so if you rotate it or find the animation, okay, let me animate. Okay, what is this pattern? Okay. I'm just to repeat one. Oh, sorry, it should be cylinder, right? Yeah, right click the cylinder made, click on animate and choose rotating Z cylindrical one direction. So it should be rotating, it will not translate. Okay, so to select play and choose loop and give value to 150 steps and play. And there you go, you can see the animation of the radial engine. You can actually see that the piston rods are actually moving out of the body. To do that, we have to make an actual character body here, and they should not be go that much down. The reason behind is the distance between of the crankshaft we have given. Okay, so if we edit it, we can do that. Now we can fix this one. Just choose first and wait. Select edge, so the center should be highlighted, connected. The same thing here, and can see the interaction intersection. I'm going to select the face, right click, and choose. You can find the section view and rotate this direction and see they're getting collided or not. Okay, if you want, you can select all the parts, right click, and choose check interference. Well, we can see the actual interferences. I think the crank, these parts are getting intersect each other. So these are the defects, but we can manage them. How? Just hide this part. It's because of the length of the crank we have given. If you can able to reduce it, you can change it. Okay, we just need to right click here, get the sketch file, and give the value to 1. Well, actually, should not getting touched to it. Let's giving the value to point. Okay, now save it. Edit the extrude 9. That's it. Now we got main interpret. Let's go switch back to assembly 3. And let's animate once again. Let's see. So if you see, it is not going much out. It totally depends on the length. It totally depends on the length, how much the distance between the input shaft and the output shaft. Okay, it totally depends upon it. So this is how you can achieve the animation and how you can actually design the radial engine. Yeah, you can find some drawbacks here. That is the design point of view, but you can make changes to it. Okay, you can make changes to the body as you want later. Okay, adding the extra diameter here that will help you to get the actual animation. Okay. Okay, that's all for the video. This is the assembly how you can design the Onshape, no, or else in any CAD software. If you really like this video, if you really like this tutorial, please do like, share, and subscribe our channel, guys. It's definitely helpful for me to get back with more videos. And if you have any ideas or if you want me to make any tutorials on specific designs, please let me know. I will make them for you and push it on our channel. Thank you.